In C, C++, and Java, the keywords break and continue are statements that must appear inside a loop for while, do while, or inside a switch break only. C/C++/Java, break semicolon, continue semicolon, note the semicolon. Python, break, continue, no parentheses, no semicolon. Break immediately terminates the nearest and closing loop or switch. Control jumps to the first statement after the loop. Continue skips the rest of the current loop body and starts the next iteration. In a for loop, the iteration expression I++ in C or Java, the increment part is still executed before the next test. In a while or do while, the condition is re-evaluated immediately. For open parenthesis int I equals 0 semicolon, I less than 10 semicolon increment, I close parenthesis open brace. If I equals 5 break semicolon comment stop. When I becomes 5, if I modulo 2 equals 0 continue semicolon comment skip. Even numbers print %d space, I close parenthesis semicolon close brace comment prints 1 3. For I in range 10 colon, if I equals 5 colon break comment stop loop, at 5, if I modulo 2 equals 0 colon continue comment skip. Even numbers print I n space comment output 1 3. The meaning is identical across the three languages, but the surrounding syntax semicolons, braces, indentation follows each language's rules. When a break statement is executed inside a single level loop, the loop ends instantly. It does not finish the remaining iterations, nor does it execute the loop's update clause in a for. Control flow continues with the first statement after the loop. Imagine a runner on a track who hears a whistle telling them to stop. They stop right where they are, they do not finish the lap. In sum equals 0, for int I equals 1, I less than or equal to 100, I++ open brace if I greater than 20 break. Stop after I becomes 21, sum plus equals I, close brace, system.out.println of sum of 1 to 20 equals 210. Here the loop never reaches I equals 21. The moment the condition I greater than 20 is true, break transfers control to system.out.println. The same behavior appears in C/C++ and Python. The only difference is how the surrounding block is written. A continue statement tells the loop to skip the rest of the current iteration and immediately start the next one. The loop's control variables are still updated according to the loop definition. Analogy: think of a conveyor belt that drops defective items. When a defect is detected, the belt simply moves the item off and continues with the next item. The belt never stops, it just ignores the bad one. For int I equals 1 to 10 increment I. If I equals 4 continue, ignore I equals 4 count I prints 1 2 3 5 6 7 8 9 10. In a while loop, the condition is evaluated again after continue. In a for loop, the increment part runs before the next test. This subtle detail is why continue never bypasses the loop control expression. For I in range 1 to 11 colon, if I equals 4 colon continue print I end equals space hash 1 2 3 5 6 7 8 9 10. In nested loops there are multiple enclosing loops. A plain break or continue only affects the innermost loop that contains it. C/C++/Java, no built-in way to break out of more than one level at once. To exit an outer loop you must either use a flag variable, test it after the inner loop and break again, or in Java, use a labeled break. Outer colon for open parentheses ... close parentheses, open brace for open parentheses ... close parentheses, open brace break outer semicolon close brace close brace. Python, no labeled break. You typically wrap the inner loop in a function and return or raise a custom exception or use a flag. Example, Java labeled break. Outer colon for open parenthesis in I equals 1 semicolon I less than or equal to 5 semicolon I plus close parenthesis, open brace for open parenthesis in J equals 1 semicolon J less than or equal to 5 semicolon J plus close parenthesis open brace. If open parenthesis I star J greater than 12 close parenthesis open brace break outer semicolon comment. Exits both loops close brace system.out.println open parenthesis. Plus comma J close parenthesis semicolon close brace close brace. Only the outer loop is terminated. The inner one is never given a chance to finish its current iteration. Example, C++ with flag. Bool done equals false semicolon for open parenthesis int I equals 1 semicolon I less than or equal to 5. and not done semicolon plus I close parenthesis open brace for open parenthesis in J equals 1 semicolon J less than or equal to 5 semicolon plus J close parenthesis open brace if open parenthesis I star J greater than 12 close parenthesis open brace done equals true semicolon break semicolon close brace std colon count. Less I less comma less J less backslash and semicolon close brace close brace. A continue works the same way. It only skips the rest of the current inner loop iteration. If you want to skip the outer loop's current iteration, you need another continue in the outer loop, often controlled by a flag. Understanding this scope rule is essential for correctly pruning searches or avoiding extra work. Explanation early exit, also called algorithmic pruning, uses break or sometimes continue to stop work as soon as the answer is known, saving time. Linear search stop when the target is found. Define function find with parameters array and target. Loop over index I and value val in the enumeration of the array. If the value equals the target, then break. After the loop, set I to -1. Finally, return I. Prime factorization, once a divisor larger than square root of n is reached without finding a factor we can break, because the remaining number is prime. Graph traversal depth first search or breadth first search. When a goal node is discovered, break or return terminates the recursion or loop immediately. Optimization in nested loops. If an inner loop discovers that continuing cannot improve the current best solution, a break exits that inner loop, reducing the total number of iterations dramatically. These uses are common in competitive programming and interview questions, where the goal is to reduce the worst case time from big O of n squared to something smaller by pruning impossible or unnecessary branches. Explanation exam-style traps involving break and continue often test whether students understand the exact scope and side effects. Fall through in Switch C or Java. Forgetting a break lets execution continue into the next case, which many students assume stops automatically. Infinite loop with continue. Placing continue before the loop control update, while I less than 10 if I modulo 2, then continue I increment prevents I from ever changing, causing an infinite loop. Misreading Python's for else. The else block runs only when the loop completes, normally no break. Students may think it runs after every iteration. Labeled break confusion Java. Some think break outer also terminates loops labeled inside the outer loop. It only exits the named loop. Using break in a do while. Since the condition is checked after the body, a break skips the condition entirely and leaves the loop immediately. Continue in a for each Java. Continue moves to the next element, but the loop variable is managed by the iterator. Trying to modify it inside the loop can cause concurrent modification exception. Goal, given an integer n, find the smallest prime p such that p is greater than n. We test each candidate starting from n+1 and stop as soon as we find a prime. The break ends the outer search loop. Mathematically, a number x is prime if for all integers d with 2 less than or equal to d less than or equal to the square root of x modulo d is not equal to 0. See implementation. Include the standard input-output header and the math header. Define the main function that returns an integer. Read an integer n from standard input. Start an infinite for loop with candidate equal to n+1, incrementing candidate each iteration. Assume the candidate is prime by setting is prime to 1. Compute limit as the integer cast of the square root of candidate. Loop divisor d from 2 up to limit inclusive. If candidate modulo d equals 0, set is prime to 0 and break out of the inner loop. After the inner loop, if is prime is still true, print the candidate followed by a newline and break out of the outer loop. Finally, return 0. Python implementation. Import the math module. Read integer n from input. Initialize candidate to n+1. Enter an infinite while loop. Compute limit as the integer square root of candidate. For each divisor d in the range from 2 to limit inclusive, if candidate modulo d equals 0, break out of the for loop indicating the number is not prime. If the for loop completes without a break, the else clause runs. Print the candidate as the prime found and break out of the while loop. After each iteration where a divisor was found, increment candidate by 1. The outer loop runs until the first prime is encountered. The inner break discards composite numbers quickly, giving an efficient big O of the square root of p search. Explanation. Below are sample exam items that evaluate understanding of break and continue. Multiple choice, choose one. Number 1. In Java, which statement correctly exits both the inner and outer for loops? Option A, break. Option B, continue. Option C, break outer. Option D, continue outer. Correct answer, option C, break outer. Short answer number 2. Explain what happens to the loop variable I in the following C loop when continue is executed. The code, for int I equals 0, I less than 10, increment I inside the loop if I modulo 3 equals 0, continue, otherwise print I expected answer. The increment I++ is performed after each iteration, including the ones where continue skips the print statement. Therefore, I still advances from 0 to 9. Coding, write a function. Number 3. Write a Python function first duplicate that takes an array and returns the first element that appears at least twice in the list. Use break to stop scanning as soon as the duplicate is found. The skeleton code, define first duplicate of R, create an empty set called scene. For each x in R, if x is in scene, duplicate found, blank to fill in, use break or return. Add x to scene, return none at the end. Solution, replace the blank with return x, or assign duplicate equals x break, then return duplicate. True or false? Number 4. A continue statement in a while loop always increments the loop counter. Answer false. Continue only jumps to the condition check. Any increment must be done explicitly before the continue. These items cover syntax, scope, and practical use, giving a well-rounded assessment of a student's mastery of break and continue.